All right, welcome back. I hope you're having an amazing time so far. Our next panel is titled NLP in Industry, Use Cases, Challenges, and Roadmap. Please join me in welcoming our panelists to the virtual stage. And I'll hand it over to Martin, our moderator.
Thank you. Hello, everyone. Welcome to this panel discussion. So let's first do the introductions. I will introduce myself the last, but let's keep in this order. Let's go in this order. Matthew, if you can start, then Kevin, and then Pratik. Thank you.
Hi, I'm Matthew Lightman. I'm a senior machine learning researcher at DeepGram, where I work on speech to text and other speech processing related products. My background's in physics. I used to do computational particle physics, and then I moved into data science in the financial industry, and more recently I've been working at startups.
Hi folks, Kevin Atkinson. I'm the head of solutions consulting with Expert.ai. We're about 30 years old and with a heritage in symbolic NLP, and we have added machine learning and deep learning capabilities to that technology over the past few years. And we have solutions in insurance, in publishing and media, banking, healthcare, across several different verticals, as well as a platform for horizontal capabilities as well. Pleasure to be here.
Good afternoon, I'm Pratik Biswas. I'm a distinguished data scientist and machine learning engineer at Verizon. I do exploratory work in NLP and recommender systems, as well as build predictive data mining models for Verizon business use cases. My areas of interest and expertise are in AI, knowledge-based systems, data science, machine learning, NLP, as well as wireless networks.
Thank you. My name is Martin Polacek. I'm lead data scientist at Comcast. So my expertise or my main focus is applying the neural nets in NLP setup. I'm really interested in chatbots, unstructured and unsupervised intent detection systems, as well as like the NLP text modeling. My background is physics, and I'm interested in all AI based. So that's great. Thank you for all those introductions, and we can move to the first question. Great. So the first question for the panel is like, broadly speaking, how are organizations using NLP? So if anyone wants to start, we can. Is anyone in the audience? If not, I can start. So in my daily job or in Comcast, we have basically the whole variety of the NLP problems, like from the speech to text to the chatbots, and to ending in some unstructured business data. So the NLP is really like in all those fields, right? So in my area or in my sub-work, we are really dealing with the business data. It might range from the survey data to the metadata, all that stuff. And one of the basic tasks we are getting is like how we can kind of leverage this data, because as you can imagine, this is like enormous set of the data that is otherwise hardly like relevant, like hardly kind of analyzable for the business. So we are providing this application of the NLP services, like as I mentioned, the unsupervised intent detection systems that can kind of go to the unstructured text data and grab those insights directly from them. So that's one big delivery that we are having currently in my company. But of course, it ranges, right? So at the Comcast, we have definitely we have the chatbot systems in place. We have the speech to text systems in place. So that's broadly how we are leveraging the NLP in our company. So if the other people can kind of jump into this, Pratik.
Yeah, so I will answer this in three parts. First, I'll mention a few use cases which are very common use of NLP, but which I haven't been involved in. For example, use cases dealing with determining credit worthiness based on credit reports, use cases in marketing analysis and advertising. And then next I'll talk about use cases that I have been involved in, but they're not necessarily part of my current work. Like, for example, email classification as spam or ham, hiring and recruitment. And then I come to use cases that intersect with my current work. So very common use case is sentiment analysis. You look at call conversations between customer and agents, and you determine if there is a possibility for that customer to churn or not. Topic modeling and keyword extraction. You look at call conversations and then identify the topics that are of utmost importance or utmost interest to both customer and agents. You extract keywords that can mean something with regards to what the customer is planning to do. Then you have question answering. That's another very typical application. You also have text classification, where you look at call transcripts and decide based on that content of that conversation or in the transcript whether the customer is going to make a purchase or not, whether he's going to make a repeat call or not. You personalized recommendation of products and services based on the browser web pages that a customer has browsed. You can potentially determine or recommend what kind of what's the likelihood of that customer buying similar products, and then recommend very similar products, and that which could enable him to upgrade his current services or products that he is actually subscribing with the telecom with Verizon. And then the most important thing that I've been involved in is called automatic summarization. So you have call transcripts that could be unnecessarily long, that can have small talks, and it's very useful if you can have a short summary describing those call conversations, which can then be serve as records or historical records for call centers, or in a very concise form can also be sent as messages to customers, reminding him of the conversations that he has had with the agents. So these are some atypical use cases that can intersect with the kind of work that I do for Verizon.
If I could just maybe add a couple of things on, I agree with that. There are some common use cases like intelligent search or knowledge management that have been around for a while, chatbots and interactive assistants. That the idea of data mining and auto categorization, and then we moved into process automation, so email management, handling a large volume of servicing requests, and so on. I think we're at the point now where we're moving into complex business process augmentation. So more kind of specific domain related, whether it's underwriting, investing, medical records, policies, or contract review, where you're now kind of getting to the next level of language understanding, of having domain knowledge built into the solution as well. And to kind of back up the previous point, we're seeing that too, of this idea of summarizing. So you have all of these different industries are flooded with very large volumes of unstructured data, and we need AI technology to look into that, pull out the important pieces, and help me optimize my time when I'm looking at that.
So at DeepGram, we work on speech processing mostly. So there's definitely some overlap with some of the stuff that you've mentioned. So for example, things that we've seen customers doing are things like taking the text that comes from speech and using it, summarization reporting based on that, like call centers or sales reps, you're taking their conversation, wanting to, flagging potential issues or looking for, indications of success kind of. So this kind of reporting and summarization that you mentioned before. And then another big application we've seen is conversational AI. It's kind of taking, you want to take the raw speech, convert that to words, and then have some sort of downstream natural language understanding to then feed that into a conversation. So those are very similar applications that we've definitely seen with our customers. And then one other thing that I've noticed, there's also just the need for like very accurate transcription of speech for things like record keeping, especially when you're getting into more technical versus specific domains. So things like the medical industry, they have a lot of jargon, or things like company meetings, they might have jargon, or they might have like overlap talking and stuff like that. And they just need kind of transcription, like accurate transcriptions for record keeping. So that's kind of another class of applications that I've seen.
All great insights. So I think that do we want any other insights from the folks here?
Yeah. Another very common application that we encounter every day is language translation, right? You go to Google Translate and you translate from one language to the other. That's a very atypical application of NLP these days. And spell check for any text editor.
Yeah, so I guess that we are facing all very similar problems here, or challenges, right? So, and all those technologies from NLP are coming into industry, and they are kind of actively used in industry. Yeah, right. So, any other insights from the group? Great. If not, then we can move to another question. What does a typical NLP tech stack looks like from the data infrastructure to tools? What's the required toolkit that you are using in your company?
I can start with that one. So I think like there's kind of, at least sort of from a machine learning kind of a framework, there's kind of two parts. There's the training, and then there's like the production or inference part of the pipeline. And I found those to be very, very different in their tech stack and implementation. So for example, when in my work currently, based on that, like I'd say in training, like the main constant for NLP related work is that there's some sort of deep learning library, something like PyTorch or TensorFlow, that you can use to train deep learning models. And definitely Python as a programming language of choice is becoming pretty ubiquitous for training machine learning models. Beyond that, I think it's there's like a whole host of different ecosystem of different tools, and it's very different depending on the nature of your data and what the size of your data. For example, at our company, we end up making a lot of custom tools for things like data serving, text cleaning and evaluation. And one of the reasons for that is we do a lot of stuff on-prem rather than in the cloud. We have like our own GPU cluster, our own cluster that we use for training rather than a cloud provider for cost-effective reasons and cost effectiveness. We have that expertise already because we use those for production. That's more common in other situations. People would be used maybe the cloud for that. And then that's training, and then there's production. I think that's less standard, I would say, because it really depends on the system that you're trying to integrate with, like what the business at large has. So it depends totally on what your constraints are in terms of efficiency and speed, and what the system is that you're integrating with. So for example, in my company, we have our production code is in Rust, and it's deployed on our own clusters, and it's sort of like highly optimized for speed and inference, and serves an API through that. But there's depending, in a different kind of business system, you could have a totally different setup than that.
Great. Mm-hmm. Kevin?
Just maybe add a couple of thoughts to that. Bearing in mind that Expert AI is bringing a little bit of additional assets into that relating to symbolic capabilities, but I agree that there's the training side and the production side. This question of what does the typical stack look like, it ranges from disparate tools to the emergence of integrated platforms as well. But just a couple of additional thoughts. tooling to assist with data preparation, we find is a kind of common requirement for data formatting and conversion and normalization. So taking different input formats, whether it's image, text, voice, video, and reformatting, converting, normalizing and standardizing that. It's helpful to have annotation and labeling technology and tooling, and there's some kind of options there. With symbolic or semantic approaches, it's also kind of common to rely on knowledge graphs and inference models as well. There might be tooling in your stack for taxonomy and ontology management, and also tooling to allow for accuracy and performance measurement. Then I guess the last point, data storage of the linguistic data insights of when you're harvesting this data from the language, there needs to be somewhere to persist that and run analytics as well.
So I will pick up from Kevin, and I guess focus more on the disparate tool set that are part of my daily activities. That's part of this NLP stack that we're talking about here. So for the language of choice for me is Python, PySpark if I wanted to write distributed code, and PyTorch if I want to use the latest transformers. And when it comes to packages and toolkits, I will mention Spacey, NLTK, GenSim, Stanford Core NLP. If I want to do this in a distributed manner, Spark NLP. If I want to build, sequence-to-sequence models, I'll use TensorFlow, Keras. And if I want to use transformers, then I use pre-trained transformers like BERT, Robata, T5, XLNet, and Albert. Now, when it comes to the framework, we use two kinds of framework. We train on GPUs, so we train on GPU queues. And when we deploy model or when we run them in production, we actually do inferencing on distributed CPU queues. So that's in short the tech stack and the framework that we use for our NLP work here at Verizon.
Thank you. Yeah, I will just jump in. Yeah, definitely very similar tech stack, right? So like in my company, we are using kind of combination of the cloud services as well as on-prem GPU clusters. So yeah, with respect to like the frameworks for deep learning, like myself, like it's open, but myself, I'm using mostly TensorFlow for building the neural networks, and all those tools mentioned like GenSim and the classical NLP tools like NLTK or GenSim. They are in my stack. With respect to like organization or like the technology that we are using for managing all those services, it's all Dockerized and managed by the Kubernetes cluster. So yeah, but pretty much the same, except like from time to time, we also try to resolve some bottlenecks in C++. So yeah, that's about it.
If I may just add, when it comes to transformers, the Hugging Face PyTorch transformers are the transformers of my choice. I do not necessarily use the TensorFlow APIs for these transformers. My work with TensorFlow Keras was confined primarily to using LSTMs and the earlier sequence-to-sequence models.
Any addition from the?
Yeah, there was LSTM, GRU, and RNN networks when it came to TensorFlow Keras earlier.
Yeah, I think it sounds like right, like so the tools for certainly like model training and stuff are pretty. You've mentioned a lot of the similar stuff, but some of the other tools like Kevin meant, some of the other parts of the tech stack that Kevin mentioned for like data curation, data annotation, very important parts. But I've seen I haven't seen as much standardization around that. Like no one names a certain package that they, or a certain library that they use for that. And a lot of like sort of homegrown custom built stuff in those spaces is what I've noticed. I'm curious if you guys agree with that.
Yeah, I agree with you. And I think that's, the reference to the emergence of platforms, those kind of capabilities ideally are built into the platform to accelerate the kind of low value pieces of the NL pipeline.
Great. If any other additions, we can jump into the next question. Okay, next question is, which challenges do organizations encounter when implementing or actively using NLP? And if you can, please share examples. If you can't, that's fine as well. Thank you. So
I will start this one. So I will pick up one very common challenge that we encounter, which is, it's very seldom that you have industry use cases that conform to the typical or classical, atypical or classical application of the, the NLP problem. For example, when we are talking about call transcript summarization, we're not necessarily dealing with, we're not necessarily summarizing stories, articles, or documents. We're dealing with, large text, which are malformed and which are unpunctuated or ill-punctuated. So standard summarization techniques would not work very well. And even if you use standard transformers, they would not also work very well because you're essentially dealing with, you've pre-trained these transformers with something else. So here, you would need to innovate and come up with something else of your own to address this kind of a challenge, where your use case would not conform to a very atypical application of the NLP use case. But that's one example.
Yeah, I think I suspect that we're all gonna say some version of like that, data is kind of like the data quality or data standards are like a big are going to be a major challenge in some form or the other. And like, is it, do you have, well, not, do you have enough data? Sure. But it's more, do you have enough like high quality data, and is it labeled consistently, or is the format that one that you can use? Like consistency is super important in data labeling. If you want to train a good machine learning model, like there's sort of this tendency for people who are less, like other stakeholders who are less familiar to think of these techniques as a black box and be like, I'm just going to throw all my data at it and then train a model and it'll be awesome. But that's not quite how it works. Like one simple example, like really simple illustrative example is, think about this, right? Like you're transcribing a phone call or you're transcribing a conversation. How do you write the word okay? Do you write okay or just okay? Might seem like a trivial thing might seem like a trivial thing, and it doesn't really matter which one you use, but the important thing is being consistent about it. If you write different versions of the same word in different places, you're going to confuse the model that's trying to learn from it. Like it's hearing the same thing, it's seeing in the same context, but it's seeing a different word written. It's just going to get confused, and it's going to lead to bad results. So this kind of like, consistency in labeling is super important. So you got to deal with that either through imposing better standards for, humans who transcribe things, or using some other tricks to normalize your data. Or another example that Pratik was mentioning is like if something's not punctuated, but you're expecting, you need punctuation in the model, you have to find some way to put some trick to put that in, some other method or something like that, or make sure that those standards are enforced.
Yep, I kind of +1 to your comments there of the dependence on training data and quality training data for each individual data point extraction that we want to make out of that can be very challenging. Noisy data, unclean data, things that, and not only are these kind of difficult, but we found that they're often overlooked. It's assumed that we can just start running full speed on AI, and there's usually quite a large effort required in curating and getting quality data to start with. A couple of other things in our experience of scaling and improving results can be challenging. So projects typically start out and incrementally increase in scope, and getting high quality results on a narrow scope of work can be pretty successful and quick, but scaling that out across a real world business problem can be challenging. And that finding the right balance of quality results without overfitting against a large volume of training data, getting good quality results. Coming back to that previous point of kind of domain-specific NLP solutions, another challenge that we found is overcoming the subjectivity and ambiguity in language. So, you find language in documents all over the place that use words that like sufficient or adequate, and it can mean totally different things, even across a team of humans that are working with that data. And so getting that kind of agreement and consistency across subjective activities can be very challenging. And then explainability. So why am I getting this result? And how does this data insight actually relate to the sourced content that it came from can be challenging.
Yeah, so thank you. From my perspective, exactly. I was facing scalability and domain specificity of those models quite a bit. And it's totally true. If you look for some solutions online that are, for example, working really well on a Twitter type of corpus, I can almost guarantee you that on a business corpus, it will fail unless you have very specific Twitter-like feed inside your business. That's one observation I had. Sometimes you have to kind of work extra and be creative, how to, taking incredibly great architecture and translate it, or even take the pre-trained model, how to kind of even use it in your business-specific setup. And that was okay, so this is all great, so we can produce some results or whatnot. But my challenge was many times, not necessarily at companies and different companies as well, how to kind of take my results or take this hype around the AI and NLP and translate it to the business people, right? So because business people, they can just read whatever is out there in the news, hey, GPT-3, it's great. So can you create the chatbot out of that? Not necessarily at the business, right? So you need some chatbots that are kind of solving your business problems, not just having some type of meaningful conversation, stuff like that, how to kind of explain what is possible in this space, really possible at business. So that was a challenge that was this, especially this translation to the business people.
Yeah, for the business folks, there's a lot of scenarios where these are very manual, human-centric processes currently. And so there's also the challenge of embedding the subject matter expertise in the AI solution. So when I look at this document and find this, then I do that. And that can be challenging to embed that knowledge and understanding into the solution.
Yes, great. So yeah, Pratik, yeah.
So another challenge that I'd like to bring forward here that we often encounter in large organizations deals with the size of the data. So when we have big data, that brings forth associated problems as to what platform do we choose to implement the use case, and what tool set associated tool set do we choose to solve the problem. So when it comes to platform, do we train on GPUs on just a few hosts, or if at all we have access to a GPU cluster, or on a single host if we don't, or do we actually distribute training through Spark to multiple executors? Likewise, when it or if it's a small data, do we actually do it on a very high-powered single host machine? Now, likewise, when it comes to deployment or production, do we actually do the inferencing in a distributed manner, distributing it via Spark to multiple executors? Or do we actually use the inference on a GPU-based cluster or a GPU-based host in a GPU cluster? Likewise, when it comes to selecting the appropriate tool set to solve the problem, which packages do we go for? For example, if we take NLTK, Spacey, and GenSim, they're primarily single host based packages, but they all provide similar functionalities. So which functionality do I choose? And depending on which package I choose, I may get different results. And so when it comes to a use case like, say, identifying the most important topics, or extracting keywords, results could be different depending on which tool set or which package you use. So these are issues that you grapple with when you try to build a model, or when you try to solve a use case involving NLP using the particular framework or the tool set that you want to use for this, to solve this use case or to address this use case. So in one word, the size of the data and the platforms and the toolkits to choose from to address this use case.
Great, thank you. Anybody else? Okay, if not, we can go to another question. That is, what is the absolute cutting edge NLP in your mind?
Maybe I'll start with just a very short, straight answer. For me, it's deep learning. At least at this stage, for me, it's deep learning, transformers, and transfer learn. And when it comes to transformers, I will name BERT, Albert, XLNet, Robota, Longformer for long documents, and T5, which can be the same transformer where it can be used for multiple different use cases. And I'll pretty much end with that.
Yeah, I would agree with, I think there's a lot of activity around transformers recently, and it seems from my experience that's pretty robust. They're pretty robust, like, it's not just hype, like that they're pretty, they give you a pretty robust improvement over other older architectures, right? So definitely +1 to that. I think, and then there's some, there's like new research coming out all the time, but that's like, I've had less experience or less chance to sort of try those things out. But things like, I know there's a lot of buzz around like unsupervised and self-supervised learning recently. I'm not as familiar with what's going on and how those work out in realistic settings, but they sound, interesting and promising. But it's, unclear. So at this point, it's like how much of a, like how that's going to play into everything.
If I may just quickly add a few sentences to it. So yes, so semi-supervised learning, hybrid summarization, adjusting your pre-training and fine-tuning to make these transformers even more robust are some of the the latest and greatest things that I can think of in these areas, in the area of NLP research.
My thoughts on this, I agree with you on the transformers. I kind of coming back to a previous point, I think the improvement or quality improvement on natural language generation and summarization, that's an area where quality of the results is, in our experience, improving significantly. Kind of disclaimer, I've got a little bit of a bias here, but on the cutting edge of NLP, although symbolic has been around for a long time, combining symbolic with ML is pretty revolutionary, I think, in that ML can have an understanding problem and symbolic can have a learning problem. And putting the two together to overcome those challenges is able to kind of address use the best of both to solve language problems efficiently.
Thank you. Yeah, I like one particular model stuck in my mind like for a long time. It was like this again, like Transformer, I love that architecture, but there was the extension of that architecture also made by Google called Reformer. And this is like the scalable transformer architecture that I think that they use two another tricks to kind of increase the ability to increase the size of the text they can kind of take into this architecture. And that was like pretty amazing because I think that they were able to take kind of ingest like half of the crime and punishment and try to kind of generate the other half. So it was like pretty amazing. So that's a pretty interesting extension of the transformer architecture I saw. Yeah, the reformer.
Yeah, just to add to that, there's a lot of research or work going on, exploratory work going on for long formats. That is to, transform very large documents, larger than the 512 tokens that we normally think of. And that's an area where there's a lot of work going on. There's Allen AI, which has its own long former. There are other people who are working in this. So that could actually revolutionize summarization of large documents once it's standardized. So to reformer, I would also like to add long former.
Yeah. Yeah. So I agree with the group. So any other great insights? Okay. If not, we can go next. How can organizations increase the ROI from NLP projects?
Sorry.
Sorry.
Okay. Yeah, I mean, I think it sort of comes back to what we were talking about in some of the challenges that we mentioned, like addressing those challenges. You'll in the right way, you'll probably be able to do a better job and get better ROI on your NLP efforts. So I guess, for example, like if organizations put in the initial effort to take data quality seriously and standards seriously, come up with like kind of company-wide standards for data labeling, that sort of thing. And process start with firm processes as soon as possible for processing data and storing it and so forth. You're gonna get a much better return on investment. Like that might seem like some effort to like get those standards together, but like you're definitely gonna get a good return on investment. Like I think a lot of organizations have lots of data, but then they it's not sort of curated in any way, or it's like there's some funny way that they're handling it or something like that. So I think putting the upfront effort to do that is going to enable you to do lots of different do lots of different things much better in NLP applications, and is definitely worth doing that. So things like coming up with internal standards for data labeling, and just being aware of like best practices for data, data collection and storage.
Go ahead.
Go ahead.
A couple of other thoughts on that. I think it's really good use of time to evaluate and choose productive tools. So I totally agree with the standardization and formal processes in place, and to avoid the accumulating technical debt and silos of technology accumulating across the organization. But evaluate and choose productive and standardized tools or a platform to work with as well. There was a comment before of Matthew, I think you said this about, the answer is it depends. How do you solve the problem? And understanding the factors which should drive how you solve the solution or provide the solution to a problem are really important. And using the right tooling, the right models, the right algorithm, the right approach, the right techniques, based on the unique factors. If you've got large training data versus small, if you've got different kind of factors. Another way to avoid or increase the ROI is to reduce cost. And there are some very expensive resources involved in NLP. That could be expensive processors and deployment infrastructure. It could be data scientist teams, software engineers, computational linguists. So really improving the efficiency and with which you're delivering these solutions, and optimizing the use of those expensive resources is really important as well.
Yes, Pratik.
So I will add more generic comments to what has already been said. First and foremost, identify more and more use cases where you can involve or incorporate textual information, and then see if incorporating that information actually increases or improves your model performance or whatever that you're trying to do. And then I would say, like, increase awareness of NLP techniques or advantages of NLP in your organization. Introduce different NLP techniques to your organization. Invest in NLP technologies, platforms, and tools, and hire more data scientists, machine learning engineers that are trained in NLP, and that will increase your return to investments, ROI.
Thank you. Yeah, I agree. Like from my perspective, what was also very effective was like education, or like just exposing this work to the business people and showing them what we can realistically do within the industry. So that was also helpful. And also, like if you have some amazing solution that could be kind of democratized, so release the internal API for the people to actually use it, right? So like it's having doing this extra step, like you have a great NLP model or whatnot that you believe that can be useful for the other people within the organization. Just try to release it at least as an internal API, so the people can actually use it. So we have one more question. So let's move this and let's finish it. We have almost just 8 minutes till the end of this session. So what do you anticipate in the field of NLP to look like in 10 years?
I'll take a crack at that one. I think it means ease of use moving forward. More platforms to work with. So you heard today kind of a list of a few, but more are emerging, and maybe they're specific to industries or domains, but I think the emergence of platforms to work with the entire natural language pipeline from data ingestion through to production. I think over the next 10 years, there's going to be a dramatic evolution in the role and the tooling of data scientists. It's already happening and will continue. I also think that there'll be improvements in inferencing and reasoning as opposed to predictive models. So not one or the other, but there's opportunity for significant improvement there, I think, in the inference and reasoning area.
Matthew, Pratik, you want?
Yeah, Matt, yes.
Sure. Yeah, no, that's just interesting. I like that actually. It's probably I like the definitely like the tooling and making this more generally available is probably is an important, like I guess I was thinking sort of more in terms of like what are like the new flashy things or the new capabilities that are going to emerge, but probably more important than that is what Kevin was mentioning, like the making it just existing tasks easier, and building out the platforms for that data scientists use, democratizing those. But I think like I guess sort of like what are like the sort of research advancements, or like what are we going to see like in day-to-day life, I guess, like what are the differences we might see. It's it's like my favorite quote is like, predictions are difficult, especially about the future. So whenever you're trying to predict technology, it's like you can do really badly. But I imagine like that you're gonna see so for example, like in conversational AI, you're going to see things that are more more generalized. Like it's not just like some like some scripted interaction. Like you say something and it has like a finite number of like responses that it can give, or finite number of decision points it can make. Something that you're going to see things that are more capable of generating like arbitrary text or speech in a response to and to you. So it'll be more like a real conversation than like pre like small number of options. And then probably along those lines, the thing that I look forward to is like I imagine there'll be a lot more like auto-generated things like news articles, captions, like I think that's already starting to be there, but like I imagine that's going to become much more ubiquitous in the next 10 years.
Yeah, I will jump in. I totally believe in like, exactly, Matthew, as you mentioned, like predictions are hard. But what I want to see, what I really would like to see it is like exactly this AI-driven, but business-oriented chatbots, right? So like this stuff that is like not rule-based chatbots that are kind of industry-wide now, industry deployed, but more like industry specific. They could solve the industry problems, but in the normal human-like conversational way. So this is still a very tough task to do with the AI first chatbots. Yeah, so that's what I really want to see.
So I will add, I have a few thoughts in this area, and I will start with generic expectations, like for example, more improved and new applications in the areas of search, customer support, telecom, educational, law, finance, etc. Newer, better and bigger NLP platforms like Spark NLP, newer and bigger editions of that. And then, I have some thoughts about some very specific applications. For example, I envisage improved integration between biometrics and NLP, improved integration between knowledge graphs and NLP, cyber NLP, where basically you introduce or use NLP in a big way in cyber security, contextualized modeling and multi-turn conversation. For example, when you right now, you ask Siri or Alexa just to, issue a one sentence command, and they execute this and then come back to you with one sentence response. You'd like this conversation to be repetitive and consisting of multiple turns based on your speech-based commands. And so we would expect an improvement in that regard, and perhaps also that would also lead to more improved chatbots. And lastly, I hope to see integration of common sense with knowledge in semantic analysis using NLP at some point of time.
I just want to maybe add, Martin, I agree with you with this domain-specific knowledge. Hopefully in 10 years from now, it's one thing for NLP to understand general language, but to understand a medical report as though it's a doctor, or understand an engineering report as though you're an engineer, that's hard. And there needs to be more open source and proprietary language models to help scaffold and accelerate projects that are aimed at those kinds of business problems.
Yeah, I think you'll start seeing more of the ability for anyone to build their own custom models based on their own data, right? Like sort of enabling not just like machine learning researchers to be able to do that, whether that's in terms of tooling of like data curation, and then the actual availability of models to do transfer learning from, and the actual tools for training. I think you'll start seeing a lot more of that's going to become more common.
Yeah, thank you. Yeah, I think that this is it. We are about to finish this session. So thank you all. Thank AI4 to kind of having us here. It was a great session. Thank you.
Oh, thank you all so much. Thank you to all of our panelists for sharing these incredible insights with us today. And a special thank you to Martin for moderating and keeping us on track. That was amazing. And I know this virtual audience is giving you a huge virtual round of applause. Thank you again. All right, for the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.